Hey everyone, I was going to start today's video with a joke generated by ChatGPT about today's topic, which is Git diffs and SVG files and how we can make it any better. So I said, hey, tell me a joke about Git diffs and SVG files. And they say, why did the developer refuse to review the SVG file in the Git diff? Because it was just too difficult to see what was changing? Yeah, if you get it, please explain it to me. I don't get it. They were all pretty terrible. I think the closest one was, why did the developer quit using Git? Because they couldn't merge their feelings about it? That one's not bad. Anyway, let's move on to the actual topic, because none of that's really funny. Right, so, issue number 200, feature output markdown file for easy Git diff and understanding. So we'll touch on that. We're going to go through a new example, which I haven't pushed yet, but will be up by the time you're viewing this, and we can play with that feature in this example. And then there's also another part I want to talk about, which is a safety concern for certain control state machines if you're doing something I call transition spamming. Yeah, so we'll get to that, but let's start at the top. So mainly there's a couple issues with using SVG files for Statesmith. They're great in many ways, but they really fall down when you try to git diff the SVG file. Some platforms like Bitbucket will actually diff the SVG file, like a visual diff, and that works fairly well if the change is small and the design is not nested. But if it is a larger design or a lot has changed, or it's nested, it really does not help. So like here's a small example. In this state machine, I just want to change after milliseconds from 100 to 200. So that's it. Here's what you end up seeing in the SVG text diff. Like if you weren't doing a visual diff, like just a command line or some other tool, you can see that it changed from 100 to 200, which is pretty good. But you can't tell what transition that was for. There's nothing that really connects it easily to the parent or the transition, the edge, anything really. So that's not really helpful there. If instead of storing our design as a draw.io SVG, we could have gone just XML, like my state machine or mysm.draw.io, the XML file. And in that case, we would have seen a git diff like this, where, it does, if you're aware of it, you can see the difference there. But again, there's a whole bunch of gobbledygook in here. We get a bunch more like HTML entities, much more encoding. I cut out all the style in here because it was too long. And then you're left with this parent and source thing. And so it's not super helpful when you're trying to do the git diff. This feature, however, it outputs a markdown file, and we'll get to that so you can see it later, but it's very clear in the git diff what's happened. So in this vertex startup beep, which is a normal state, there's its diagram ID, this is its parent state, here's all its behaviors, and boom, there's the diff that we wanted to see. So I really like it. One of the other things that we'll see too is you can use it when we enable some extra features to output ancestor behaviors too. So if we want to see all of the behaviors that could happen in a particular vertex, we enable a setting, and we get not only the behaviors just for preheat, which are these ones, preheat state, but from all of its ancestors as well. So this can be really helpful if you're working in a deeply nested state machine, or you're just trying to wrap your head around some stuff. And eventually that kind of feature, being able to see all of the behaviors, will hopefully make its way into the Statesmith user interface plugin. And yeah, this is an example project to do. That's because it's not posted. And then there's one other feature which yeah, we'll just jump into it. Okay, flipping over to the presentation, the example. Okay, so it is, let's let's get over here. SM design describer -1. I've opened it just in that directory so we can see it without all the other projects in there as well. And if we close the VS Code part here, because we don't really care about that, there's a diagram here, which is pretty simple. None of it actually really makes sense, but there's a couple cool things that are going on here. We've got a trigger map here that maps any, like this, any trigger here to the wildcard. So we'll see that this gets expanded, or it gets mapped to every possible trigger in our design. And actually, now that I think about it, there's not too many there's not too many different triggers in here right now. So let's add another one quickly. Let's just go on press stuff ++. Okay, we'll add a new one in there. And yeah, I've got this set up here. So here's our CSX file with all the different settings that you can uncomment below. So the first thing to do if you want to have this work or have this new feature is you have to use version 0.9.8 or later. And then the rest of it is kind of standard except for these settings right here. These are the settings that you have to use to enable it. So by default, we're not going to generate this markdown file. That one right there. But if you want to enable it, here's the path. And by default, let's run our little script here. Okay, that's done. Let's jump over here. This is what it's going to look like. And it's already doing the git diff for us, or Visual Studio Code is showing us, hey, this is what changed right here, which is really handy. Some tips for navigating this file. I don't know if you've seen this before, but in Visual Studio Code, there's this outline down here. And if you open it up, you can easily jump to the different states in here, or the different sections or headings in a markdown file, which for us are our vertices. So if we wanted to jump to, let's say, preheat, we want to see, the description of what preheat does. You can flip back to here and go preheat. And there it's got it highlighted. Now, if we had a much larger diagram and we didn't want to use the outline, you can also use the symbol explorer. Actually, I'm not sure what it's called. I just go Control-Shift-O. You bring up your command palette, do the @ symbol, and start typing in the name of your vertice. Preheat, and it takes us right there. So by default, this is what it shows us. It's basically exactly what's in the diagram. Now, there's some different settings that we can enable, and we'll go through them one at a time here. Right now, what's happening is we're seeing the state machine description, or the design description, before any transformations happen. If we want to, we can also add to the output the after transformation section. So we'll run the script there and we'll see the difference here in a second. So now if we take a look at our outline, we have a before transformation section and after transformation section. So after transformations basically means that we've stripped out all the nodes, we've ripped out the render config nodes, like this kind of stuff here, and these here, and it really is it's basically the state machine graph, or whatever you want to call it, tree, before it hits the state machine code generation. So now if we take a look at, let's look for the root in this one. So yeah, here's root. So after transformations, it looks like this. We've got the do event and the press event. If we just want to see root, we can use our symbol editor, Control-Shift-O, or sorry, symbol explorer or navigator, and we can kind of flip between them. So after transformation, it looks like this. Before transformation, it looks like this. So any is what was shown in the diagram, written in the diagram, and that gets expanded to do or press after transformations. You can see other examples of that if you get into fancier stuff. Yeah, I won't touch on that too much. There's other example projects where you can add custom logging for enter and exit, and if you want to do scripts like that, being able to see what happens just before code generation might be really helpful. All right, but for now, we'll just disable that, and we're going to enable the output ancestor handlers instead. So we'll fire that off, give it a second or two, and let's see what's changed here. So again, we just have the before transformation section, and yeah, we can jump up to here, and now what we see is, like, for the vertex normal, we now have everything from the root. Sorry, I just thought of one other thing I want to say. Right, so for every vertice now, it basically shows every ancestor event handler in the kind of hierarchy chain going upwards. Now you might ask, why is it sorted this way? Luckily, in this example, root ends up being the first one, but what's actually happening right now is they're sorted by diagram ID, and because diagram ID is a string, it's like string sorting. So it's not ideal, but depending on which editor you use, it might be all numbers. If you're using the VS Code unofficial draw.io extension, not made by me, it's going to be numbers. If it's the draw.io one, it's going to look something like just garbage, garbly goop. And so we're using string sorts for now. The reason for doing that is to try to keep the order relatively consistent. So even if you take a state and you move it around in your diagram, like if I was to grab this one and yank it over here, because the diagram ID hasn't changed, it should hopefully minimize the changes in our markdown file here. That's the main reason for the sorting there. But yeah, here's a kind of more interesting node or vertice here, where our startup beep node, it inherits this error transition and also the any kind of event trigger, which logs an unhandled event. So now hopefully this has generally made sense, and feel free to let me know if it didn't make sense or if something is unclear. So let's jump into the part where there could be a safety concern. I've been meaning to make a video for this for a long time. It's just been busy around here, summertime, I tend to be more active on Statesmith in the winter because it's cold outside where I live. Right, okay, so in this scenario, we've got this error handler here. If this error condition is ever true, we want to go from the normal state or any of its substates over to the error state. And that works perfectly everywhere except for here, basically. I guess perfectly is the wrong way to describe that, and we'll touch on this in a second here. But it breaks, or it could really get messed up right here. There could be some serious latency or get stuck in this state. And the reason for that is the design intent here. Oh, darn it. Double-clicked by accident. My mouse is on the fritz. The design intent here is for preheat to stay in here for 200 milliseconds. That is kind of a ridiculous number. It should be like, multiple seconds, but let's just pretend that that is a reasonable value. Anyways, it wants to stay in this state until it is no longer too cold for 200 milliseconds. And so what happens, the way this is achieved right now, is it enters the state, and every time there is a do event, it checks both of these transitions And if we wanted to be a little bit more careful, we could probably put this one at 2 because we want to check that one after this one. So a little bit more careful. It would check this one first. It would say, hey, is the too cold condition true? And if that's the case, then it exits, re-enters, clears the timer. And it basically is going to do that every single do event until we're no longer too cold. And so when we're warm enough, it's going to check this condition. Have we been in here 200 milliseconds? No. Have we been in here 200 milliseconds? No. Until finally it is, and it takes this transition here. So this is one way of kind of achieving that, wait for a certain thing. There's different ways of timing this, but the main real problem with this, and it's written over here, so maybe you've already read ahead from me, from what I've been blabbering on about. But the basic problem is that both of, like this transition here, actually we've got it down here, enabling that feature where we can output ancestors makes it kind of easy to look at right now. If we're looking in the preheat state, here's its description with all of its inherited behaviors, or most of its inherited behaviors. I cut off the bottom ones that didn't matter. You can see that both the error handler and the too cold kind of like handler happen on the do event. And if we're transition spamming, like doing this over and over and over again while we're too cold, we cannot take this error transition, just because when a transition happens, that's it. Your event is consumed, it's over, we're going to wait for the next event dispatch. So this can be a relatively dangerous pattern to do if you do anything like error kind of handling like in this diagram, or if there's other situations you want to avoid. Now, there's an easy fix for this. There's multiple easy fixes for this. One is don't do this transition spamming, which also might be a pain for people who are doing logging on enter and exit. Like, you probably don't want to do this anyways. But if you're not doing that, and this is a convenient way, you can keep that in there. But to keep your diagram safe, you should no longer rely on the do event, because if you haven't come across this yet, if you don't specify a trigger for a behavior, it comes across with an implicit do on the do event. That's basically what this is here. And if we want to make sure that our error check happens irregardless or regardless of what a substate is doing and maybe consuming it, a helpful way to do that is, say, write a whatever your error test or something like this. So maybe after every dispatch, you do this error. You also send it the error test event. And that way you can keep on doing your regular transition spamming in here, but then, so you basically send your do event to your state machine, then you send your error test. And if we, just for fun, let's run our code generation here. Come on, draw.io save. All right, there we go. So we'll run our code generation this time, and we're gonna navigate to the preheat in our markdown. So let's go preheat again. And now if we look at it, we can see that these no longer clash. The do event on this here will not prevent this error transition from happening. That's about all I can think of to kind of share from here. Have fun, explore, goofing around with these, and if there's something missing or something that we should change or tweak, let me know. One of the other ideas that I had, which might be kind of interesting actually, is, to be fair, it might take me a while to do this because it is a fair amount of work. It might be useful to not only show ancestor events handlers, but on a transition like this, maybe it would be cool to also show like this will exit blah, it'll do this, it will exit blah, it will do it'll execute, you know, some sort of other transition code, action this, and then it'll enter some state, and it'll enter another state. And so the idea here is that if you wanted to be able to really understand at a glance everything that can happen in a behavior and the full effects of it, you would be able to see like, oh, this transition to error, like this one right here, if we were in the preheat state, right now there's no real exit handlers, but it could show you the exit handlers and all the different actions that will be taken, and the enter handler here. Anyways, if you think that would be useful, let me know. If not, yeah, I hope you're enjoying your summer, and we'll catch you later.